So today we're in our second semester final exams, so we have focused on all of January through May's material. Our first day is all about exponents and factoring. Factoring and then, double distributing or foiling, multiplying. So I've got the entire packet in this slideshow, but I cannot do every single problem from all, 4 pages? So I'll do a few from each section, and then that'll leave you to finish off, and after you've seen my examples, then you'll be able to successfully finish the last few from each section, okay? So a basic review for exponent properties. The exponent properties are listed just like you see it. When my exponents are multiplied, the bases are the same, right? X and X are the same. I'm going to add my A plus B. That's called the product property. So right now I'm just rereading what's already on your paper. Then the example would be, you first do 7 times 4, 28. Then you do the x squared times the x to the 1, and the x to the 1's in parentheses, which is x to the third. You add 2 plus 1. And then the y's is just going to be y1 times y1, and you add 1 plus 1, y squared. So that would be the answer to the example in the chart. A power means that you're going to multiply the exponents out. So on this here, you'd multiply the a times the b. And in the example portion, 2 goes to the third power. X squared goes to the third power, and 4 goes to the third power. And I'm realizing how small this is for you, and I apologize for that. The 2 goes to the third power. What's 2 times 2 times 2? 2 to the third. What is it?
8.
2 times 2 times 2. X squared to the third. X squared to the third. So it's like 2 times 3. X to the sixth. And how about y to the fourth to the third? So 4 times 3. And you would leave your answer just like that. On number, and let me try and zoom in on this. I think I can. Wow. Hot stuff, right? All right. We haven't had one like this before with fractions, but there are some like this on the final. When you have division, you subtract the exponents. So I'm going to subtract 1/2 minus 1/4. That's like half a dollar, take away 1/4 of a dollar. 50 cents, take away 25 cents. Change it to money if this helps. What's 50 cents minus 1/4?
Minus 75 cents or 3/4.
Oh, why? You said the word 7 and I wrote 7. Ah!
I'm not going to make mistakes. That was recorded.
1/4. Though, the mathematical way is to find the common denominator, which would be 2/4 minus 1/4, and the answer is 1/4. So adding and subtracting fractions means that you find a common denominator. Since I subtracted these 2 fractions, I had to find a common denominator, but I knew that you could do this in your head because the fractions were easy. So that was helpful.
So what's your final answer?
1/4.
Wait, why?
Oh, final, I'm sorry, x to the 1/4.
Wait, but why?
Because I subtract 1/2 minus 1/4. 1/2 minus 1/4 is 1/4. So x to the 1/4 power.
Got it.
Negative exponents. Right. Anytime you have a 0 power, it's 1. X to the 0 is 1. 2 to the 0 is 1. Okay, don't get confused with the one I'm about to do. Only the x is to the 0 power. So this means 2 times 1. 2 times 1 is actually 2. Okay, this whole parentheses is to the 0 power. So the whole thing goes to the 0 power, which means it's still just a 1. On the last example, the 3 is just doing its own thing. But this 2 to the x is to the 0. So 2 to the x to the 0 is 1. So don't forget about the 3. 3 times 1. Okay? Negative exponents. I've got an x to the negative second power. Negative second. What happens when I've got a negative exponent? What happens to this x?
It goes 1 over.
1 over becomes a fraction, a number smaller than 1. My exponent is then positive 2 because I moved it down to the denominator. And I would leave my answer like that. 2 to the negative second. 1 over 2 squared. Right. 1 over 2 squared, which is 1 over 4. The next problem. The denominator says x to the negative first. Well, that's needs to move. Only the denominator moves. Where does the denominator go?
Nowhere.
No, it has a negative exponent.
Does that become positive?
It becomes a positive, but I have to move it somewhere.
To a whole number.
Up. Yes. So now I have 2 times x to the 1. Nothing on the denominator anymore. Well, that's just 2x. The parentheses means the entire 2x is to the negative second power. So the entire parentheses moves down to the denominator. And it becomes a positive 2. But I still don't have the parentheses gone, which I really need the parentheses to be gone. So this is now a power to a power, because the parentheses. So what do I do with the 2? And what do I do with the x? You like it, distribute, it's a fine word, yeah. 2 goes squared, x goes squared. 2 squared.
4.
I'll write it out all like perfect, but you can do it in your head, right? 4 x squared. On this one, it's very similar to the last problem we just did, but the 3 is going to not move at all. Only the 2x goes down to the denominator. So the 2x moves because of that negative 1. But now it's a first power, and that's just a first power. I don't even need the parentheses with first power. 3 times 1 over 2x. 3 is on top, 2x is on the bottom. That's all you do. 3 over 2x is your final answer. Okay. Fractional exponents. I'm going to say for sure over a month since we've talked about this. The top number stays with the base. The bottom number goes to the front for a square root. Remember this? Been a while. So that means I have the x to the a. The numerator stays. And the b moves to the front and becomes the root. The b root of x to the a, which we can't even solve or do anything. You just leave it. Here,
Do the circle thing.
the 2 to the first power stays like this. But then I'm going to bring that 3 to the front. And really, the third root of 2, I can't do anything. You can't, there's nothing, what times what? 3 times makes 2. There's nothing. This one I'll be able to do. The 25 stays to the first power, but the square root. What's the square root of 25?
5.
Good.
Because 5 times 5 is 25.
Ooh, I like this one. 8 squared, and then the third root. Okay. Something I want to talk to you about. The third root of 8. Because this says, I'm going to go like baby steps. Right? 8 times 8 is 8 squared. Do you agree? I know you feel like I'm going backwards and I should have put 64. Here's the reason why. Because 8 is a third root. 8 is a cube. It's a, what number, this times this makes 8? 2. So here's what I'm going to do. Prepare for your mind to be blown. I'm going to write 2 to the third instead of 8. And now, because my 3's, remember how, I could do my little target thing. Remember how this 3 and this 3, when they're the same number, they cancel each other out? Remember that? And this 3 and this 3 are the same number, so these two are going to cancel each other out. So a 2 will come out. This 2 will also come out. And they'll both be out. And I have 2 times 2 equals 4.
Oh, I see.
All right. Rational, okay, so like the 1/2 and the 3/8. The 1/2 and the 3/8. Am I supposed to add them, multiply them, or subtract them? What is the, look at the top of your paper. What does the rules say? Add them.
Add them. Wait, what did it say?
1/2 plus 3/8. Make them both common denominators. And now I need to make my new fractions with the same denominator. 1/2, okay, well, 2 times what equals 8? 2 times 4. So I do 1 times 4. 1 times 4 is 4. It's in light blue. Sorry if you can't see it very well. 3/8 just is going to stay 3/8. What's 4/8 plus 3/8? 7/8. But remember, this is just my exponent. So my answer is x to the 7/8 power. Oh, that's really hard to see. X to the 7/8 power is my answer. Okay, these types mean you just break it down.
Break it down.
So, obviously the square root of 16 is the easiest one. It's just 4. But,
75.
like 88 and numbers like that mean that you have to like pick a perfect square. Pick a perfect square. Yes. What are my perfect squares? Someone. It's okay, you forgot. 4, 9, 16, 25. So, yes, these are the numbers that you're going to pick to break it down by. So, 75, you would pick 25 times 3. Because you've got to have a perfect square in there that you can take out. 25 comes out. The square root of 25 is 5. So it comes out as just 5. And then 3, poor 3, wham, wham, all alone by itself. Inside. Okay. 108. 9 times what?
12.
Ooh, but 12 has a perfect square in it.
Yeah, it does.
9 times 12. 12 has a perfect square. Break down 12. 9 times 4 times 3. So anytime that you can think of a perfect square that it's divisible by, you need to write that down. 9 comes out as 3. 4 comes out as 2. And the rad 3 is all alone. So it's 3 times 2, rad 3. 6, rad 3. Right? Okay, like I said, there's no way that I can literally do every single page in every problem. What's happening is you've got this next page, the back side, where I will show you all of the answers tomorrow, but I'm not going to do every single problem. I will do problems randomly. So I'm going to do right now number 4, because I think that people might... Let me expand number 4. Whoa, what's that?
What are those?
Okay. 3 gets squared. X gets squared. Y gets squared. Okay. Everything goes to the second power. This is power to a power. My final answer... All right? And on this chunk of problems, this is the only one that I felt that you might actually struggle with. So this is the only one I'm going to do in this chunk. I'm going on to the next group. For some reason, my thing skipped, 7 and 8 and 9. But here... Oh, look at number 12, you guys, real quick. You can't do one single thing except for bring that x to the third up. The only thing you can do on number 12 is bring the x to the negative third up. So my answer is going to be 10x to the third, y to the fourth. You always write your variables in alphabetical order. So I put the x before the y. Alphabetical order. Nothing's on the denominator for number 12. On number 4, I would subtract, is the really easiest way. Negative 10 minus negative 2, right? Negative 10 plus 2, x to the negative 8. The negative 8 brings it down to the denominator. So that's it for that. Yeah. On 18, the only thing I can think of that might be difficult is that you've got to multiply the 1/2 times 3, which becomes 3 halves. 9 to the 3 halves. The 3 stays with the 9. The 2 goes to the front. The square root of 9 to the third. I want to zoom in on this because I now need more space since it's in the corner. Okay, this again requires you to be careful because I have a third root underneath and only a square root outside. So it's going to become this. The square root of, and I'm going to break my 9 up so that it's going to match up with a squared. And it's going to look like this. 9 squared times 9 to the 1. Doesn't 2 plus 1 make 3? So I broke this third down into 2 plus 1. The reason, now I've got matching 2 and 2. See these 2's that match? Look at my little thing on the screen. These now can come out. If I would have left it the third power right here, I would have really been like, you might have gone, what's 9 times 9 times 9? And done that math and then tried to square root that. You'd be like in a world of hurt. So, this 9 comes out as just plain old 9, right? The 2's cancel. But I still have a 9 left. Can I do anything else? Look at it. Square root of 9. What's the square root of 9? 3. It comes out as a 3. My answer is 27. All right. Okay, good. So let me jump to, okay, these are extras. Oh, 21. I know there's one like 21 on the final. 21 is the one I want to focus on. Because the first thing I need to do on 21 is add the numerators. Add the 1/3 plus 1/6. X to the 1/3 plus 1/6. They need to have the same denominator. X to the 2/6 plus 1/6. Right? Isn't that how I change the denominators? What's 2/6 plus 3/6? 3/6. Reduce 3/6. 1/2. So now my math problem says this. X to the 1/2 over x to the 2/3. Turns out that now I'm subtracting. I don't move anything to the bottom. There's no negatives anywhere. I need to subtract 1/2 minus 2/3. 1/2 is smaller than 2/3. You're going to have a negative answer. This problem just takes a while. 1/2 minus 2/3 is going to be a negative number. Find a common denominator of 2 times 3. 6. Three times 2 equals 6. 2 times 2 equals 4. 2 times 3 equals 6. 1 times 3 equals 3. My math problem is now 3/6 minus 4/6. So, x to the... Aww. Hold on. Blackout. Seriously? The whole school? Internet either. Because my computer. Can I? Okay, yeah, it's still recording. 3 x to the negative 1/6. The negative exponent drops down. And it's positive 1/6 on the denominator. Okay, I think I have to go to the chalkboard now, you guys. Is that okay? All right. So we just did number 4, and we got this. Let me write it out. I can do a different color as soon as I'm finished. There we go. This 3 comes out. This 3 comes out. This 3 comes out. 3 times 3 times 3 is 27. Okay? So your job with these is to break it down so that your root matches your inside. So this 32 squared would become, because 2 to the 5th is 32, 2 to the 5th, 32, and it's 32 squared. So I have to write it twice because it's 32 squared. 32 times 32. 2 to the 5th times 2 to the 5th. So that's your whole goal. Making it all match up. Making my 5s match here and my 5s so that I can pull out a 2 and then pull out another 2. Okay, the answer to number 5 is 4. Pardon me. Okay, I'm not going to do this page. All right, real quick. Jump. Domain means all of the x's. Range means all of the y's. Function. Do any of my x's repeat, yes or no? Are any of my x's the same? No. Then yes, it's a function. Yay! Y. all the x's are different. With number 2, you would have to just write out what the ordered pairs are. -4, comma 0. -3, comma 2. -2, comma 2. See how I'm just writing out whatever 0, 0, wherever the dots are? 3, comma, -1. And then you just list it. What are all the x's? -4, -3, -2, 0, 3. Okay? Turns out that yes, this is a function because all of the x's are different. And, you know, it passes the vertical line test too, so there's that. Remember we talked about that yesterday, the vertical line test?
Yeah. You move your pen.
Yeah, none of my, oh, vertical line. This is a horrible, what am I don't know, I'm sorry. Anyways, the point is it never hits twice, okay? Yeah.
So, like, we have 2 as a range for, like, different, like, points. Do we have to put 2 twice or is 1 just okay?
I would write it twice just to be thorough. But look at your multiple choices and see what you get. Okay. The domain and range for this one mean where does it start on the x-axis and where does it end on the x-axis? There are no arrows. Notice there's no arrows like saying it goes on forever and ever. So my domain is going to be all real numbers. Whoa, huge. But my range means where does it top out and where does it bottom out? What's my y range? 1, no, +1 and -1. Look, you guys. Oh, sorry. It's a 1. My range is in between -1 is between and +1. That's how we write it when we say something's in between. Is it a function? I'll use the proper tools this time. Does it pass the vertical line test? If I draw straight lines, does it hit twice? Anywhere?
No.
So yes, it's a function. Number 4, straight line. The domain is always all real numbers because this line will go on forever and ever. This is cut and pasted from a calculator image, but it will go on forever and ever. And then the range is going to be all real numbers again. Okay? Does it pass the vertical line test? Oh, it never hits more than once. Yes, it's a function. I'm moving on. Ooh, does number 5 pass the vertical line test? No. Because it does not pass the vertical line test. Not a function. Okay? On number 6, it's quadratic. Stay with me because I'm not slowing down for you. It is a quadratic because you got the little squared there. That's the dead giveaway. The squared. F of x, you know f of x is the same as y equals x squared plus 2. Okay? It's a parabola. It's going to be just an average looking parabola with my y-intercept at +2 because of this. Let me see what else I'm missing. If there's anything super important that I got to hit, I'm going to hit it. Okay. Oh, remember this? Combine like terms. Keep the same backpacks. So I want all of my x squareds to go together. Look at these n squareds. 7n squared minus -2. 7n squared plus 2n squared. This negative sign needs to be distributed to all of those numbers, which means you change the sign. I think this is fairly easy for you guys, yeah? Yeah. Then let's do just the n's. 8n minus 6n, 2n. Then let's do the plain old constants, the numbers. -8 minus -8. Oh. My final answer for number 1. In order, 9n squared plus 2n. Same thing here. Let's go to 4. Everybody go to 4. Underline things that are the same, or put like notifications to yourself, like circles or squares or triangles or stars or whatever. So everything that matches up, that's what you add together. If they have the same, you know, it's a really helpful way for you to make sure that you're combining like terms properly. All right, I'm going down to 7 and 8. If it has a squared and a plus sign, it means you write it twice. Write it twice, then you do your double distributing. Here's my answer. 9v squared plus 24v plus 16. Number 10, same thing. FOIL or double distribute. The answer is p squared minus 1. All right. Do what you can.
For your book.